So I think the last presentation of the day is Laura Niles again. She's already been introduced. So I think you're doing the good, bad, and the ugly of stations.
You want to brag where the station is?
Well, I don't know if I want to brag. That's our in-course station at Del Paso Manor. People talk about the 1950s station you have to live through. There's one right there.
And we got a really good station operator there, too. I want to mention that. Want to raise your hand? Since we get to see your picture all week? Yeah, Raj. Okay. I guess I got to do this. Okay, good, bad, and ugly. The station operations group asked me to talk about this. It's kind of what we see out there in real life. And so they just kind of asked me to take a look. And sometimes things don't look so great. The purpose of the audit. The purpose of the audit is not to give you guys AQDAs or cans. We do not like to do that. It takes a lot of time when we get back. It takes a lot of review before we issue these AQDAs and cans. I know it takes a lot of time on your end to take care of them and write them. So that is not the purpose. It is the purpose, though, to challenge the instrument, confirm the accuracy, and verify the quality control and complement efforts for data completeness, data quality. This is what I wanted to show you. It's just a picture of our audit board really quick. A lot of times when we ask you guys, we're usually giving you a good 30 days in advance when we come out. So if you can see the ones there on your right, those are what they call fly days. We fly down on Monday, leave the van there all week, and fly home on Fridays. So we can change things within a week, but it's really hard when you start asking us to change to another week because it really affects how we station our van and our things. You'll drive Chris Diedrich crazy. So anyway, but we are really pretty flexible within a week. But I wanted to show you guys how tight our schedule is when we come out and audit, especially in Southern California. Purpose of the audit, you kind of seen this all day, but here I kind of want to show where the presentation line goes. We have a 150-foot reel. We challenge your probe with gases, your analyzer. Inside the van, we have pretty much the same setup as a station, so pretty much we're running back and forth all day long, taking points. I wanted to, we never take pictures of good stuff. We always tend to take pictures of bad things, except if they're your kids, obviously. But in this case, I found something good, and it was this is in Ventura County, and they use a stanchion to lower their Met tower. And they purchased a winch, which was fairly inexpensive. I think it was only a couple $100. They installed it themselves, apparently, so it saved a lot on labor costs. But this way, people don't get hurt when they're lowering towers. So you're going to lower your tower a little more often when you don't have to do it hand over hand. I know some people have cranks, other people have other things, but there are still people out there doing towers hand over hand. Anybody hand? You got a hand for people? Yeah, there's still people doing hand over hand. That's a back killer. So some of the most common issues, I think we've kind of hit it over and over today. Trees and obstacles, inlet spacing, inlet lengths. I'm going to have pictures of those. Something that I kind of became recently aware of is the federal requirement, the federal reference method for the inlet height for an FRM is 2.0 plus or minus 0.2, and that's usually not a problem because an FRM is usually set. It's your RMP 2000s, RMP 2025, 2025I. But what about BAM inlet heights? They're FEM. It's not addressed. But the only place I found it in writing is our ARB's SOP, that their guidance is that we keep them 2 meters above your roof surface. How to avoid siting issues in the first place. If you listen to Jaime's thing today, a lot of it was talking about how to avoid these. So if you review these when you're getting ready to go to sleep, you'll do fine. But usually the SOPs, ARB's SOPs, are a pretty good way to take a look at those first before you start looking at federal, because they're a lot easier to read and they're a lot more user-friendly. Documentation, I think we've killed you to death with documentation, but we're going to actually show you some examples. But first we're going to go over siting. I think we had some questions earlier about trees. The red line represents the tree drip line. The yellow equals the cone of influence at a 10-meter radius. So that, in this case, is this tree within the drip line, is it within the 10 meters? Yes or no? Yes. So what do I do? Cut the tree down, right? We can move the sampler, right. There's a lot of things we can do. But more than likely from an audit team, you're going to get a can. The worst part about this is you're going to get a can. Okay, this is where some confusion lies when we talk about the cone of influence. The yellow is, again, the 10-meter requirement. So you're 10 meters away from your drip line, right? But I got a very tall tree next to my sampler. So in this case, my tree is 10 meters above my sampler head. So how far does it have to be from my sampler? Twice as far. So it's got to be 20 meters away. So does this meet the siting criteria? No. So big thumbs down. Okay. This is how we normally go out and do measurements as the audit team. So we're double checking what you guys have. In this case, the inlet height was less than a meter from a parapet, and a parapet is basically a false wall, and they're usually around roofs to hide HVAC equipment. That's usually what a parapet is. And so in this case, we got a lot of before and after pictures. The operator was able to raise the inlet height so it was greater than a meter from the parapet. Another siting issue. How high does an inlet have to be for most instruments and probes from the ground? I heard a bunch of different ones. Minimum of 2, no greater than 15. 15, no greater than 15. So if you're on a 3-story building, you're cutting it close. So just be aware there's a siting. So this is something that we saw out in the middle of nowhere, and this is how they fixed it. So be careful because this supervisor told them to raise it in inches, and we are dealing in metric. So just be careful about that. Okay, this is the history of a tree. This is in the year 2000. Yeah, trees are a big problem here in Northern California. Not so much in Southern California, but in Northern California, they're a huge issue. So we got a tree. The yellow circle represents the probe and BAM. 2007 still exists. Not much has changed. What's tricky is as auditors, when we go out there, we get a little trick sometimes when there's no leaves on the tree. So just be aware that it's still too close. There's still a drip line there. We just can't see it as well. 2012, we've now cut the tree down, and we've paired away, but we still got the 2 trees in front of the BAM. 2014, these trees have actually been trimmed below the BAM inlets. However, there's maintenance every year that requires these to be cut. So the best thing is either to move the station or cut the trees, or you got one more option. Raise the inlet, or exactly, get the EPA waiver. Talk to Gwen, right? Gwen's saying, no, no more waivers. Okay, so here we talked a little bit about palm trees here. Palm trees, in this case, the drip line of a palm tree was within 8 meters of our sampler. And in this case, it was a PM10. Is this a problem? Remember, it's a drip line, right? But they don't really say what kind of drip line. So, yeah, it is a problem. Fortunately, when I went out there this last year, the tree had grown so tall it's no longer an issue. So, because this was taken a little while ago. But this was an issue. Here's another before. And here's the after picture. It's kind of like seeing those makeovers on TV, you know? Kind of great. Okay, another issue we have is, this is what gets us into trouble, is when contractors are drilling holes for you in your roofs, 1 yard does not equal 1 meter. So you can get into trouble with your spacing and your inlet spacing requirements. I think Tony had a little story about drilling holes, right? Yeah, you want to talk about that for a quick?
Testing. Yeah, my name's Tony. I went to my site to meet the contractor. They're going to put new BAM inlets through the roof and had a hard lid ceiling, so I could not see under the underside of the roof. I pointed out to the contractor where I want the 3 holes. I had a co-located BAM and a BAM PM10 that's going into Yuba City. And I marked on the ceiling, coordinated the exact location of the holes. I left the site and came back the next week. The roofer came, in between that time and put the roof holes aligned with, they tried to align with the ceiling holes, but wasn't able to because there was some rafters in the way. So it was like an unforeseen thing. You can say where you want the holes, but unless you're actually crawling into the attic, you don't know what obstacles to avoid. So we had to realign the holes in the ceiling.
Right. Great.
And that's something to look at.
Yeah, so so here he is. He tried to do the right thing. He tried to get the inlet spacing right. He had to get the BAM situated in his office right? Because you got to figure out where to put it there. Yet there was a problem with roof beams. So going through ceilings are pretty tough, as you guys know. Parapets and walls. This is another site. We're within a meter of the parapet, and we're also a meter within off the ground. Anybody see any other problem here at this site? Safety, yeah. What else? I'd hate to be up there when it's raining. But yeah, what else? Trees, exactly. When this site was put in over 20 years ago, that fruitless mulberry was probably well below the roof line, and now it's way above. Apparently, I've heard that this probe has been moved way over to the back and on top of the parapet. So, trees just seem to be a problem. Luckily, this site's not for record. If you guys go to Yosemite, on top of the visitor center, you'll be able to see the PM10 and the BAM. Is Half Dome an obstacle in this case? No. I just wanted to show you one of the nice sites we get to go to. It's Turtleback Mountain in Yosemite, not Yuba City, Yosemite. Okay, we talked a little bit about residence time. It's calculated anytime there's a change, tubing change, removing of an instrument. Remember to know the inner diameters of the stuff that you're dealing with, the length. Hockey puck size matters. We talked about that, and here's a little bit of an example. In this case, we show that this is with an API instrument, so it changed it by 4.8 seconds, just the hockey puck size. So just be careful when you have these lower flow instruments. You got to do some makeup to get through that hockey puck. But 13 seconds, they meet the requirement. Okay, we talked about all these before. All these dates have to be available when we come out there, and many times they're not. But the biggest one that we don't find out there when we come out there is the ID number of the standard that was used to calibrate your instrument, and the date it was certified. So those are the hardest things to find. The best thing to do is, as the operator, should write those down and not wait for your calibration sheet to come to you. Because many times there could be a 2-month delay by the time you get your calibration sheet from the time that we come out. So, especially if you were calibrated right before we came out. BAM certifications, that's something new that we're checking. I think you guys talked about the 5 different things, the clock timer and all that stuff. We're asking for 6 months of that you show us that. The certification for MET 1 looks like this for the newer certifications. We are now checking it against your calibration screen. Again, remember, I think Jaime mentioned the power went out and the little battery wasn't changed. This can change your calibration setup screen. So we want you to check this annually to make sure that your calibration setup screen and your MET 1 certification match. If you've had a power outage, make sure you cross-check it again. Logbooks. I think we've kind of beaten documentation to death. A lot of people are documenting, but they're not quite documenting the right things. So what do we like to write in? Everybody likes to write in pencil. No, I know, but anyway, it's got to be written in pen, and we'll show you an example of that. Here's an example. Some of the things that are circled, it says both are in P2.5s, but I don't have an ID number associated with that. The leak check was good. Throw me a value. Throw me what standard you used. Throw me the date that standard was certified. You know, we're documenting, but we need to document a little bit more, so when like people like Alita go back 5 years later and try to run this down, we can kind of compare if we were having a problem with the flow standard. So those are type of things. We don't know who wrote this. There's no initials. We have a date on the left side, but we don't know who wrote it. So those are some of the things you're documenting, but it's not quite all there. Whiteout, EPA has seen whiteout, so not a good idea. Use the idea that Alita said, cross out, say why you crossed out, initial and date. Logbooks. This is a site where we get to go to, and I never saw the station operator. It was actually it was the QA person that we had to deal with. So he had no idea where everything was, but he didn't need to, because everything was right there, the logbooks. Now, this is an instrument logbook. Why would you want to have an instrument logbook? Because the logbook travels with the instrument. That's exactly right. I come out twice as loud as you, Eric. So anyway, yeah, so all the calibration information, and then they even say what the ID number of the instrument is on the logbook, and identify the logbook as to that instrument, and then tell me everything what's been going on with that instrument. Really great idea, and even tells them what to say, what is required inside the logbook. Some of the problems that we have is audit access. In this case, we had to park at the bottom of a hill, basically, go through the trees around a trailer and up to another trailer to get it. So we used 150 feet of our access line. So again, audit access is an issue. So think about that when you guys are moving your sites. Again, we talked about this 220, 50 amp. See, these are things that EPA has sent pictures in of. We don't get to see things this bad in California. But anyway, this is called a wetting FRM PM10. So the inlet is slightly cocked, and it's held together with masking tape. Do you think it's actually an FRM? Do you think that makes it a federal reference method? Probably not. Okay. Again, we talked about how things being too close to a road, not far enough from a road with the near road stuff. Again, you guys just realize that I know this has been shown quite a few times, just realize there's one for gases and there's one for particulates. Temporary construction? Can you flag this as temporary? Probably not. So just be careful. If there's construction going on, you might want to think about moving your sampler that's going to be a little bit too long. Right now, we got our temp sensor located in the bush, and our wind speed and wind direction is a little bit cockeyed. And so the after picture shows that the bush has been cut down, and that our temp sensor has been raised, and the Met Tower has been straightened. Probably a little bit more accurate that way, right? All right, good sighting? Got a little bit of a tree problem here, right? Our PM10's over there on the left of your screen, and our Met Tower is right. I think Patrick Rainey said he went out to this site, and he said the trees were blowing like mad, but the anemometer was not spinning. So anyway, that's all we have, and I think I'm sure there's some closing remarks.